All right, so 我们继续啊 let's continue 啊。Okay, so now for 1.2, we're going to talk about standard electrode potential. So what is called standard electrode potential? It's the situation where when the potential difference across the cell terminal, when zero current will act as a mover or electric pressure that push the electron through the external circuit. And this potential difference refers as electromotive force, EMF, or the cell potential force, E cell. Means that the potential that across the what you call, okay, the situation where the potential across the cell terminal. Okay, we said the cell terminal is which one? You see, in this case, okay, let's see the, okay. Now, you can see from here, there's two terminal involved, okay, here and here, okay, as the electron. So these are the terminal, but is there any battery? Is there any battery involved? Here. No battery, right? No battery means that there is no current. That's why it said, that's why in the what you call that, in the definition, in the definition, it said zero current means that no load. Okay? You understand? So the EMF value of this cell is at standard deviation. We call it as a standard electrode potential. Okay? So the what you call it, the electric potential difference is only coming from the electron reactivity, or sorry, electropositivity or electronegativity of the substance. Okay, remember last class I think I provide with you a electropositivity chart. Okay, so now, so the standard deviation condition for the what you call that? We call this for this cell is the aqueous concentration of ion must be 1.0 mole per dm cube. The temperature is 25 degrees Celsius. Okay, we call this as room temperature, or 298 Kelvin. Okay, the atmospheric pressure, the pressure must be 1 atm or 101 kilopascal, and the platinum that used as electrode must be inert electrode. What is called inert means that it will not change before and after the reaction. Okay, we said inert, it means that very stable substance. Okay, so jot this down. Don't draw first. Later I will show you the drawing. Jot this down first. Okay, hello. I'll see. Done, let me know. Kashvin, maybe you have to, maybe you jot down I have for you.好了，什么？不是 inert 是我们一个形容词，讲它极度稳定。在 chemistry 来讲，我们讲它 chemically inert，就是讲它是在化学上它是极度稳定啊。极度稳定就是说它不会跟别的很难，或者讲很难跟别的物质发生任何化学效应。 意思它不会跟人家有 react 的，因为它很稳嘛。所以 that's why 哦，它除了 under extreme condition，extreme condition 就是说那个 condition 是可以改变它的结构的，比如超高压、超高温啊，各种形态是会导致一个物质结构变化，从物质 A 变物质 B 的啊，那种情况它才会受到影响啊。Done? Catherine, okay, I'll wait for you. Let me know if you're done. Okay. All right. So let's continue. Now, in electrochemistry, we said standard electrode potential E naught, okay, is defined as the measure of electrode potential compared to hydrogen cell with platinum electrode at standard condition with the aqueous concentration of ion at 1.0 dm cube, okay, temperature of 25 degree with a pressure of 1 atm or 101 kilopascal. This is the one, okay, under standard what you call standard condition. So that's why the standard electrode potential is the measurement, okay, of the electrode potential difference. Okay, because you see, after when we connect like this, this is actually called Daniel cell. So when you connect it like this, without battery, however, due to the difference of electropositivity of the substance, it will shows value on your voltmeter. And this value is what we call the standard electrode potential. Okay, so because we have already mentioned on here, so I didn't ask you to copy now. So now let's see. Okay, as we know, the electrode potential energy in each half cell, this and this half cell is different. Okay, for example, Daniel cell, the electron in zinc has a higher potential energy compared to copper. This is due to the electropositivity. Okay, so that's why here higher, here lower. So the electron will be pushed from zinc to copper via the external circuit. Okay, so this potential difference between the molecule now will produce a measurable value of a cell EMF in volt unit. Means that there will be a value. So in here, there must be the electrode potential energy of zinc must be is greater than copper. That's why the electron will rotate like this. While this we call it a salt bridge. Salt bridge that is actually to provide a place. It's like a wire. It's like a wire so that the electron can be go back here. Because a circuit is considered closed when the electron can be flow, right? So this salt bridge is prepared to let the electron flow from here to here. Okay? So this is what we call the Daniel cell. Okay, any questions? No, so jot this down. Okay, jot down this. The half cell is considered here. Here is one half, here is another half. So normally how we know which one is half? We just follow the electrode. This is the electrode. Okay? Okay, Dimitri done. Done, let me know. Okay, we wait for others for a while.什么东西？用眼啊，它是好像其实就是 wire 这样，普通的 wire 它不可以放进去里面呢，就是因为 why we use salt bleach instead of copper wire? Because copper wire comes with electropositivity. So when we put inside, it will actually affect the value. OK，因为它本身是有 electropositivity 的，所以它会影响那个 electron flow. It will affect the electron flow. However, salt solution is something which is neutral. It's fully neutralized. So that's why we put salt bleach is to make sure that it will not cause the solution to be reacted. 明白？就是讲它不是不要给它让它有那个什么，因为它稳定性高嘛。Salt bleach 的话，正常来讲它的稳定性高嘛。所以它的这种 salt bleach 不是那种又会溶在水里面的那种，我们用的是那种不会溶在水里面的。OK， Done? Này, rất là khá simple ha. Done, huh? Okay, done, huh? So then we continue. Okay, so let's continue, huh? So let's see the oxidizing agent and reducing agent that based on the standard electrode potential value. Okay, so like I said, okay, there is a positivity and negativity value, but this chart is actually including all. You see, we have a positivity and negativity both inside. Okay, so let's see. So electrochemical series. Oh, an electrochemical series is a series of elements that arrange according to their standard electrode potential. Because last time when we just learned electrode positivity and negativity. But how many positive or how many negative, we don't know, right? So for this one is to show the real value. Okay, so your hydrogen electron is assumed to have zero standard electrode potential value. Why? Because we set it as the reference point. So reference, like your numbers, digit, we start from, all the numbers start from 0. So that's why we are using 0 as the, what you call, as the datum point. We call the reference point. That's why hydrogen is 0. So the electron potential is defined in the form of reduction. Okay, reduction means that from positive to negative. Okay, the lower the location in the series, the more negative it is, or the lower the value. Okay, you jot these two first. Done, huh? Okay, so let's continue. Now let's see the value. Okay, as we always know, normally you see the fluorine has the highest what you call fluorine has the highest value, which is the plus 2.87, followed by sulfate. This one is manganese, chlorine, and so on. Okay, if we want to see the normal negativity one is normally the one with negativity will be metal like uh, lead, sternum, okay, followed by lead. Okay, the highest, the low, the what you call it, the most negative one will be lithium and potassium and calcium. Why? Why this one a big difference? This one why is negative? Because according to our reaction, who is the one who release the electron? Normally, is metal or non-metal? In ion, who is positively charged? Matter is the one with positively charged, correct? So he is the one who released the electron, correct? So of course, because he released the electron, so that's why the value will be negative. Okay, because an electron will be released from his side, so he will be more negative when you measure, correct? Right, the temperature. When he release heat, temperature go high or go low? Go high, ma. Because release, ma, you are measured the surrounding, so the surrounding go higher. Same goes here. He is releasing electron, so the negativity is higher. While compared to this one, non-metal, okay, they are the one who receive the electron. So less electrons surrounding their electron. So that's why they are more positive. Okay, so that's why from here, a more positive electron value is more easy to reduce. More negative, more easy for oxidation process. Okay, jot down this one. Done? Done, huh? Easy, this one, huh? All right, so let's see the process like I say. So the more positive the standard electron potential value, the easier the chemical species to undergo reduction, which is it will be the strong oxidizing agent. So the more negative the standard electron potential value, the easier the chemical species to undergo oxidation, which is it will be a strong reducing agent. Okay, so this is like what we just now already mentioned. Okay, so now let's see the formula of the what you call the value of the cell potential. So the cell voltage is equals to is equals to cathode minus anode. Okay, so just jot down this formula. This one we already jot down. Just jot down the formula. Okay. Uh-huh. Okay. Done. Huh? All right. So let's see the first example. Okay. Let's see the first example. So now a magnesium. Okay. The magnesium electrode in magnesium sulfate solution, and copper in copper electrode in copper 2 sulfate solution. So magnesium, the value of is negative 2.37. This one is positive 0.34. So who will be the negative terminal? The one with negative will be the negative terminal. So magnesium will be the negative terminal. Copper will be the positive terminal. So the oxidizing agent will be copper because it received the electron. Okay, while reducing agent will be magnesium because he released the electron. Okay, now when we compare, but he didn't. Okay, so when we compare the value, okay, so how much is the what you call that the value? The value will be by using cathode minus anode. So cathode minus anode. Okay, minus negative. So now for this one, copper. Okay, copper electrode in copper 2 sulfate solution and argentum in argentum nitrate solution. So from here, copper sulfate will be plus 0.34, argentum will be 0.8. So which one will be the negative? Negative, we choose the one with a smaller value, which is copper, while the argentum will be the positive terminal. So the oxidizing agent will be the argentum because it released the electron, while the reducing agent will be copper because he received, this one received, this one released. Okay, so the value will be 0.8 positive minus 0.34. Okay, if you get negative means a negative, you get a plus. Okay, huh? All right, so let's have a look on 1.2. Yeah. So try this. I try to change the color because the color doesn't seem okay. Try to do these two questions. This one pretty easy, just calculate only because we already provide you with the value. 你只要搞清楚哪一个 you just need to make sure which one is oxidizing, which one is reducing. Done, let me know. Done. Okay. Okay, Nana. So let's see the answer. So let's see the answer. Okay, for this one, okay, we see zinc is receiving 2 electron into zinc solid. This one is receiving 2 electron into copper. All right, because normally if these two like this, so we will choose the one with most negativity as the negative terminal, which is anode. So you use this one is cathode, this one is anode. So cathode minus anode, so 0.34 minus negative 0.76, which is 1.1. 对，它的 positivity 越高，它就是在 cathode 是加嘛。OK，so For this one, okay, we just refer to this. Normally, the positive value will be because you see these two also, both are receiving electron. So it means that they are actually extracting the electron from the solution. So what they do is, so we cannot compare here. What we can do is only compare from here. So compare from here, negative will be the anode, positive will be the cathode. So we use 0.8 minus negative 0.4, which is 1.2 as well. Okay? 看啊，做对吗 ？Dimitri 文宏 Justin。OK 啊，all correct 啊。So let's continue. So voltaic cell. Okay, so let's see what is called voltaic cell. Voltaic cell, unlike just now is two different solution, two different electrode connected by a salt bridge. That one is called Daniel cell. Voltaic cell is one solution, both electrode connected together. Okay, so it's actually a electrolyte. We call it aqueous electrolyte with metal A as electrode A, metal B as the electrode B. So this one doesn't need a salt bridge because it's not separated. Okay, so a simple voltaic cell consists of two different metals, this one A and B, which are immersed into electrolyte. Okay, and connected. Oh, this one I don't know why I didn't highlight. Immersed into an electrolyte and connected to galvanometer or voltmeter that records a reading. So the potential difference between the two electrodes will cause the movement of electron that produce the electric current. Okay, so jot this down with the drawing as well. Okay, you have to remember the name. Okay, Daniel cell with salt bridge, voltaic without salt bridge. Okay, done. Done. Let me know. Okay, done. Okay, all done. So let's continue. Okay, so let's see the first example. Okay, so this one, please take note, because this is sometimes when it comes out, when I'm afraid that they comes out in essay. Okay, so let's see how we write down this. So a zinc and copper electrode in 1.0 mole per dm cube dilute sulfuric acid. Okay, normally they will use acid as the dilute acid as the what you call the aqueous solution, because acid itself when ionized, okay, when it's ionized in aqueous solution, it will release hydrogen and SO4. Okay, which is very, I mean, is very convenient for the movement of electron. Okay, so you see, so now the negative terminal anode and the positive terminal anode. Okay, so negative terminal will be zinc because it's a stronger reducing agent as the source of the electron, where zinc will be released, will release through electron, become zinc ion, while the terminal positive, which is your cathode, will be copper. Okay, so the half equation involved, like I showed you just now, which is zinc release, zinc becomes zinc ion by releasing two electrons. While the positive terminal, okay, we will be the hydrogen. Why? Because in electropositivity, electroreactivity chart, hydrogen is higher. The position is higher compared to copper. Okay, is higher compared. There are two ways. One is the location of the position of hydrogen is higher than copper, maybe. The other way is because of more hydrogen, the quantity is very much until it cannot be, you can only choose that one. Although the position might be higher a bit, but because the quantity is very much, so it will tend to go for the more quantity one first. Okay, it's like when you are trying to, when you go to the fun fair, those small kids will like, they will tend to like take up the ball, right? The ping pong ball in the water, right? So mostly, if mostly orange, so then the tendency to get the ball will be orange. So that's the same idea here. Okay, so that's why the hydrogen will be reduced into hydrogen gas. Okay, means that hydrogen ion receive one electron each and combine into hydrogen gas, where they undergo reduction. Okay, so the thing, the what you call that, the product form. Okay, the product form at negative terminal will be zinc ion, while the positive terminal will be hydrogen gas. Okay, all right, so jot this down. Okay, this one also run, jot down this one as well. Okay. Let me know. Okay, symmetrical. Done. Okay, so let's continue. So then we have to see the observation. So the observation at the terminal, you can see the negative terminal. For negative terminal, the zinc electrode become thinner because it has been ionized. Now, for the what you call positive terminal, nothing happened to the electron because copper is not being reduced. Okay, so but because hydrogen is being reduced, in hydrogen ion become hydrogen gas, so you will see colorless bubble. Okay, so the direction of the electron, it flows from negative terminal to positive terminal. So it's from zinc to copper. Remember, okay, electron flow from negative to positive, current from positive to negative. Okay, so the voltage value will be 0.34, which is copper, minus negative 0.76 equals to 11 volt. Oh, sorry, 1.1 volt. So that's the voltage value. Okay, okay, got this up. Okay. Okay. All right. So let's continue. So now for the second one, okay, this one, because we have already have one, so we doesn't need to copy of everyone. So magnesium and ion electrode in 1.0 mole per dm cube dilute sulfuric acid. So the electrode, which is the negative terminal negative, which is magnesium, aqueous, okay, the what you call that, the positive ion will be hydrogen, okay, because the ion position is lower, okay. So that's why they will use hydrogen. So of course, the negative terminal will be the anode, which is magnesium, which is because it's a stronger reducing agent, while positive terminal is ferrum ion. Iron, sorry, it's the iron. We call it as anode. Anode, cathode. Okay, so magnesium will release two electron and become a magnesium ion. Okay, and it undergo oxidation process, while hydrogen will receive electron and become hydrogen gas, which is undergo reducing process. Okay, now the product is magnesium ion and hydrogen gas. So the observation, the magnesium electrode become thinner, while the positive terminal, the colorless gas bubble will keep release. So we know that, like I said, electron flow from negative to positive. So from magnesium to iron. Okay, so the voltage value will be this one. Okay, so this is pretty simple. Now, so let's see. In Daniel's cell, a zinc is immersed into the what I call zinc electrode is immersed into zinc sulfate solution, while copper electrode is immersed into copper 2 sulfate solution. Then the two solution are separated by a porous pot. Porous pot or connected by a salt bridge. Porous pot means that the pot with lots of hole, but the hole is very small, so that the electron can go in and out. Okay. Now, so the function is similar to salt bridge. Okay. So jot this down. So the function of porous pot is to complete the circuit by allow the ion to pass through it. Okay. Okay, Dimitri done. Done, huh? All right, so let's continue. So, like always, what we do just now, lah, okay, like always. So, first, the negative terminal will be zinc electrode because it's a stronger reducing agent, okay, compared to the what you call zinc and what you call that, or this one is zinc sulfate. So, zinc sulfate is okay. So, zinc is stronger than hydrogen, okay. For positive terminal is copper electrode. So in negative terminal, zinc will be oxidized, become zinc ion. Copper will be reduced into copper ion will be reduced into copper. Okay. Now the product form, the form here will be the okay. This one is this one doesn't need. So this one is a half equation. So for product, in negative terminal will be zinc ion, while positive will be the copper metal, or we call copper deposit also can. Deposit means that something that we grab out from the reaction and then drop down. It's like a sand and something like that. Okay, so the observation in negative terminal, the zinc electrode become thinner. Positive terminal, the copper electrode. Now we have more copper, correct? So that's why it will mix the copper electrode become thicker and thicker. Okay, thicker and thicker. So the direction move from zinc to copper. So now, wait now. All right. Then for the change of color, so the blue color of copper 2 sulfate will be decreased because it keep change into copper metal. Okay. So the what I call the voltage value will be 0.34, which is from copper, minus negative 0.76, which is from zinc, and the value will be 1.1 volt. All right. So jot this down. Okay, done. All right, let me check. We have okay, I think we can at least finish this one. Oh yeah, I have to announce. So our class for January will end here for not today lah. I mean until Saturday class. This Saturday end, then we will have 3 weeks holiday. That's your year-end holiday lah. Okay, this is also why I didn't charge for the January as well. So 3 weeks holiday. Then the week before your school open, we will start back our tuition. So the Monday, Tuesday, the class will be as usual on 10th of February. Okay. Then like always, we will keep doing until normally. I think this year your SPM will be going front as well. I think will be on 12th December. I think starting. Starting on November. I thought it's December because last time we. Oh no, I mean the paper. The paper. Should be start on December like always. They want to shift back on January to start the class. So maybe December you will start your exam. So like always, that one later on, because well, our government, Malaysia, they can change everything last minute. Like this year's what you call it, this year's SPM, they give the schedule on November, no problem. So we don't know what happened. So we will just see. Okay. So now let's see vortex cell. So a vortex cell, normally we call it as the chemical cell, can be constructed by using two different types of metal electrode, A and B, in their respective aqueous solution, and then connected by a salt bleach. And how we write it, it will be like zinc. Okay, we will start how we write it. We start to write it like zinc, zinc solid, then the solution is aqueous. So zinc aqueous, zinc ion aqueous. Then this double slash means connected by salt bleach. Then after connected by salt bleach, what it touch first? It touch the aqueous first. So that's why it's copper ion aqueous and then copper solid. So you see, solid aqueous double slash, then the slash touch aqueous, then solid. So solid aqueous double slash, then aqueous solid. This is how the sequence you don't like think that, oh, I think is just now you just memorize the halfway. So you say solid aqueous double slash solid aqueous. Wrong, straight away zero. So you must be remember how we see this is by this starting from here, solid, then touch the water, the solution aqueous, then salt bleach double slash, then the salt bleach touch aqueous again. So aqueous, then solid. Okay, so this is how it looks like. Okay, 你可以用，也可以不用。Okay, so okay, that's how he asked, because just now what we draw, the vortex cell is only involved one solution. It can be one solution, it can be two solution with salt bleach, or another one. Just how you copy what's that? Porous pot. So porous pot can also be represented by double slash. So you see, double slash here considered as the salt bleach or porous pot, while the one slash represent the boundary of electrolyte. Boundary of electrode and electrolyte. That's why we need this is to differentiate it up. Okay, so this is how. So this one I don't think you need to draw, as we already just now draw this, right? So you just jot down this and this whole thing. We call this as a cell notation. Okay, we call this a cell notation. Okay, those who have copied down, then you are allowed to dismiss. Okay. You guys still going to school? Or already start sendiri letak holiday? Because no class, I think they will just gather you in the hall or something to watch movie, I guess. Tomorrow already didn't go. Only last day, only my time last time, we need to go because they will still take attendance. Normally, our teacher will start teaching from 5. Today, take money and penvampayan. What's that? Oh, those what you call the result thingy, is it? The reward, the performance, like the best, what you call, you guys got nowadays still got the best student award or the what you call, best what you call that, what you call that, Coco performance I don't think you guys still have the best student award. The moment I back here, I don't think I saw that before. But my time in normally in like my time in Selangor, yes, my school did have best student award for each tingkatan. I have been because I was in second time for 2 years, Form 3 and Form 4, and then Sungai Besar Form 1 and Form 2. So that's why I think I have get for each tingkatan. Last time I don't know why, but Selangor they like this kind of award, the top best student award. So for each tingkatan, normally one guy and one. No, ours is 2 guy, 2 girl. I have been taking like 4 years. Then when I was changed back here, right? Suddenly I found they don't have this kind of thing. Even the best sportsman award also don't have. You guys only have, they give what you call, they just give a small medal maybe for those who have win some award, many award, something like that only, I think. Like ours, our scout, what you call that? What you call cadet police, we are quite strong, But when I'm back here, right? Nobody learned this. They only keep saying what you call that. The one is very famous is always the PB, not PBSM. Then another one, the Europe one is St. John Ambulance. I don't know why. St. John Ambulance is not even recognized in Malaysia actually. Malaysia is PBSM. Pulang Sabit Merah, Malaysia, we like a Malay way. Oh yeah, Dimitri gonna punch me after this. But quite fun. When I was back here, I saw out that the what you call Interact crowd is very famous here. Ours, right? When I was in Selangor, nobody go into pretty funny. Okay, so I will stop here for today. So see you. Bye bye.
Bye bye, 老师。Sayonara.
Okay, see you. Bye bye. Bye bye.
Just on.
You're allowed to dismiss.
Just on.
Okay, bye bye.
Just on.
哎，你讲什么？我没有听清楚。
Just on.
哦。
有我安静呢。
哎，好了，写好了的，可以先下课哦。
拜拜。
拜拜。
Just on.